this concept called as electric potential, which is voltage, yeah, in other words. Electric field is a force field. That means when charges is there is going to be certain force are going to be acting on unit positive charges, unit +1 charge. Imagine you have an electric field in the blue direction here, represented by the blue. What it really means is if I bring in a +1 charge, it's going to experience a force in this direction. That's what it's going to mean. Now, if I bring in a Q, a charge Q, instead of +1 charge, if I bring in a +Q charge, the force it's going to exert, the electric field is going to exert. This is the force exerted by the electric field. Force exerted by the electric field. The electric field is already there, and this is the force exerted by the electric field, which is going to be Q times E. Because E is by +1 charge, you multiply by Q, that becomes Q times E is the force experienced by the exerted by the electric field on the Q charge. But now, if you don't apply any force on Q, right, it's going to move down, isn't it? It's going to naturally move down. To retain Q in its location, you need to externally apply a force. The external force that you apply is this guy, so that the Q does not move even in the presence of the electric field. So you need to apply an external force. That external force must be equal and opposite to the force exerted by the electric field. That is when static happens and then the charge is not going to move anymore. So that is going to be negative Q times E. So this force has to be the external force. This is the external force needed to place Q in its place. So is there a work done by Q when, let's say, you're moving it by a small distance dy? If you want to move it above by a small distance dy, what is the work done? You know the work done is going to be force dot displacement. Work done is force dot displacement. It's exactly the force that you externally apply to the displacement that it has had is going to be the small little work that you have done. Now, instead of moving just dy, if I were to move in from a point P1 to another point P2, if I were to move that charge from this point to this point, I need to apply an external force. And since there is a displacement, means I have done some work, and this work becomes, I have expanded some energy, and that energy becomes the energy for the charge. Electric field lines are acting down, the external force is acting up and moving it from P1 to P2, from P1 to P2. And that external force is going to be equal and opposite to the direction of Fe, and that becomes negative Q, the electric field, because electric field is acting down. In terms of electric field, it's going to be negative E dot dl. That's the work done. As you can see, that work done is going to be proportional to the charge. Just like how you defined electric field to be the force experienced by unit positive charge. Electric field is the force experienced by unit positive charge. Similar to that, you are defining potential to be the work done on a unit positive charge, on a unit positive charge. So it means you take Q equal to 1. If you take Q equal to 1, when I move from P1 to P2, with respect to 1, my potential has increased to potential at 2 minus the potential at 1. The potential at 2 minus the potential at 1. So this is the voltage at 2 with respect to 1. With respect to 1. WRT means with respect to 1. Yeah. Relative to this position, I want to find what is the potential energy here. Then it is this height that I want to find, right? It's the height of the point 2 minus the height of point 1. So it's mgh2 minus mgh1. So it's V2 minus V1. So electrical potential energy is very analogous to gravitational potential energy. Gravitational potential energy, the force field is gravitational force field. Electrical potential energy, the force field is the electric field. So then you've defined voltage is negative P1 to P2 E dot dl. It's a line integral. And just like gravity, if I were to move this remote, not just in this direction, but if I were to move it in this particular direction, for example, from this point to this point, which is a height h, you know that this has mgh because of the height h. If I were to move it in this direction, for example, go all the way and then reach this point, still the work that is done is mgh. Whether I do the direct path or the convoluted path, it's still mgh, because it only depends on the final point minus the initial point. The voltage at the final point minus the voltage at the initial point. The potential at the final point minus the potential at the lower point. It does not depend on path, because the force field is conservative. The gravitational force field and electric field are conservative force field. Meaning that if you were to do the integral E dot dl, it does not depend on the path of integration. It only depends on the destination and the source. It's always the destination minus the source. Destination minus the source.